Today we're going to talk about multiplying our polynomials. In 7.2 we talked about how to add and subtract them. Today we're going to talk about how we multiply them. Back in chapter 1 we learned about how to use the distributive property, and when we are doing our polynomials we can use that distributive property again to multiply two different binomials. Remember, binomials referring to a polynomial with two terms. So here's, for example, 1. If I'm looking at x plus 2 times x plus 5, what I would basically be doing is I would say x times x is x squared, x times 5 is 5x. Then I would move to the second term within that first binomial. 2 times x is 2x, and then 2 times the 5 is plus 10. Once I've kind of broken up those parentheses, now I can kind of get at the like terms. I can certainly combine my like terms, which would in this case just be the x's down the middle there, and I can simplify by saying x squared plus 7x plus 10. And that would be the answer after I multiplied those together. So for example B, same thing. We have two different binomials that we're trying to multiply together. Obviously the parentheses makes me have to multiply everything in the first group by everything in the second group. So again, I would start with the x from the first binomial times the first term in the second binomial to get x squared. I go back to the x to multiply it by -4 to get minus 4x. Then I would go to the 3 to get 3 times x, which is 3x. And then again to the 3 times -4, which is minus 12. Once I combine my like terms, x's can go with x's, we would get x squared minus x minus 12. And that would be your answer for that. The next way we can multiply binomials is called the box method. So how we're going to do the box method is that we are basically, when we have two binomials, we're kind of moving here, we have the two binomials, we are going to make a box where we can put the different terms that we are multiplying together on the outside, one for each row. So we would have 2x and a minus 3 for the first binomial, and for the second binomial we would do each in its own column. So we would set it up like this. So then what we're going to do is we are going to take each of these one at a time. So the first box is going to be 2x times x, which is now 2x squared. We would then take the 2x times the 5 to get 10x. We would then move down to the -3 into that lower left-hand box to say -3 times x is -3x, and then the -3 times the 5 over here is going to give me -15. Now again, if you notice in this box, the first upper left-hand corner is the only term with x squared, so 2x squared is going to be combined. Then when I look at the upper right hand and the lower left hand, I see x's in both. I can add those two things together to get 7x. And then the lower right hand corner is the lone constant. So I would get x squared plus 7x minus 15. So again, for example 2, I would have my box, two binomials. So I would need 2 columns and 2 rows. And it doesn't matter which one I put across the top and which one I put across the bottom, but we'll just do the r minus 5 on the rows and the 2r minus 1 for the columns. And again, upper left-hand corner is going to be the r times the 2r, or 2r squared. The upper right-hand corner will be r times -1, which is -r. The lower left-hand corner is going to be -5 times the 2r to give -10r. And then the lower right-hand corner is the -5 times the -1, which is going to give me a 5. And then again, once we have that part figured out, we can just piece together the boxes on any of the like terms. We would have 2r squared, negative 10r in the lower left, minus 1r is negative 11r, and then we have a plus 5. So that would be your answer using the box method. So besides using the distributive property or the box method, there's also another way of doing multiplying polynomials or two binomials called the FOIL method. The FOIL method is really very, very similar to the distributive property method, but the idea of the FOIL is that it has the acronym that will hopefully help you remember each of these steps along the way. So here's how we break it down. So basically the F is going to stand for the first terms. So the very first thing you do is you multiply the very first terms of each binomial, in this case x times x, which is going to give you x squared. Then you move on to the O, which stands for outer terms. What that really basically means is the first term, or the farthest to the left, times the farthest to the right. So the most outer terms, x times 2, which is 2x. Then you would move on to inner terms, or the I. And the inner terms would be the two that are on the inside, so 1 times x, which is just x. And then the L would stand for last term. So that's going to give us the FOIL name. And so you would take the last term of the first binomial, which is the 1, times the last term of the second binomial, which is the 2. 1 times 2 is 2. At this point, what you're then going to do is you're going to basically take all of these together and add them with the like terms. So here you would have 2x plus x that we can combine to make the 3x, and you get the x squared plus 3x plus 2. So again, it really is the distributive property again, but it does give you, by having the name attached to the acronym, a way to kind of remind yourself what has to get done in what order. So here we have an example of multiplying these binomials using that FOIL method. So again, as I look at the F is going to be the x. It is going to be the x times the x, which is going to give me x squared for the F. Then I'm going to do the outside, which is going to be x times the negative 6, which is a negative 6x. Then I'm going to go inside, which is going to give me negative 3x. And then I'm going to do last. Negative 3 times negative 6 is a positive 18. And again, I can combine the like terms with the x's down the middle, and I'm going to get a final answer, which is simplified to be x squared minus 9x plus 18. For letter B, again, the same exact pattern. We're going to do 2x times 3x for the F, or first, which is going to be 6x squared. Then we're going to do the outer terms, so the 2x times the negative 5, which is a negative 10x. Then we're going to do the inner terms, 1 times 3x, which is 3x. And then we're going to do the last terms, 1 times negative 5, which is negative 5. And again, once we combine the x's down the middle there, we are going to end up with a polynomial that is 6x squared minus 7x minus 5, and that'll give us the final, most simplified answer after multiplying together those two binomials. So next I want to show you how we do the same thing, basically, when we're multiplying a binomial with a trinomial. Remember, binomial means two terms, tri means three, so that would be a three-term polynomial. And again, it's very similar to what we have done so far with the distributive property. You could make this with the box. It's probably just as easy to do your distributive property just again. But what you have to remember is with the distributive property, each term in each of the polynomials needs to get multiplied by each term in the other polynomial. So in this case, we're going to have the same exact start. X times x squared is x cubed. Then we would move on. X times negative 3x is negative 3x squared. And then again, one more x times negative 2, which is going to give me negative 2x. That will cover the first three terms, multiplying by the x in the first binomial. Then we're going to go to the 5 and do the exact same pattern. 5 times the first x squared is going to give me 5x squared. Back to the 5 times 3, negative 3x, is a negative 15x. And then one more time, the 5 times the negative 2 is a negative 10. So again, now I need to look to find my like terms. Well, I actually have a couple of different ones that I need to focus on. I see x squareds with other x squareds. I also see x's that can go with other x's. So as I'm putting all of this together, I've got to keep in mind the terms that can go together and the terms that cannot. So I only have one x cubed, so x cubed is going to be fine. When I do negative 3x squared plus 5x squared, we end up with 2x squared. A negative 2x minus 15x is a negative 17x, and then a minus 10, and that will now give me the simplified polynomial after multiplying together a binomial and a trinomial. So now we want to use a real-life application to see how these all kind of go together and how they work in a real-life situation. So here we have the picture of an ice rink where the game hockey will be played. They're showing us this trapezoid that goes down in this little corner here behind, it's bouncing all over the place, behind the goal. Okay, so that is the picture of the trapezoid. So we want to write a polynomial that represents the area of the trapezoidal region. Well, area of a trapezoid. So the formula for the area of a trapezoid is 1/2 the height times base 1 plus base 2. Remember, base 1 and base 2 are the two sides that are parallel to each other. Remember, trapezoids always have one pair of parallel sides. The height, remember, is always the altitude or the line that comes down and creates the 90-degree right angle to one of the bases. It is not necessarily going to be one of the sides. In this case, you can actually see how the height is the piece that's coming in right here, which is making the 90-degree right angle with that lower base, which is x minus 7. So what we're going to do is we're going to fill in the pieces here. So we have the area is 1/2. The height, as I just said, was x minus 7. Then in parentheses, my base 1, we'll call the base 1 x plus 10, just as that lower base. And then the upper base, which is the other parallel line, which is going across the top, is simply x. So now we're just going to see what we can simplify here. Well, I can certainly combine things inside the parentheses. I see x's that can be added to other x's. So I probably want to make this less of a complicated problem by putting together the x's to make 2x plus 10 inside the grouping. There's really nothing I can do yet with the x minus 7 and the half. We're just going to leave that there for a little while and to kind of see what actually happens here. So the next one I'm going to do is I'm going to take and use my distributive property, or actually my FOIL method, very similar, and I'm going to multiply the x times the 2x. So we're going to bring down our 1/2 for now. X times 2x is 2x squared. Then I'm going to do my outer terms, so x times 10 is plus 10x. Then I'm going to move into my inner terms, and I'm going to do negative 7 times 2x, which is negative 14x, and negative 7 times 10, which is negative 70. So hopefully we can all see how that is kind of developed and broken up those two binomials. And then we have to remember we do have that 1/2 times all of that stuff there. So what that 1/2 is going to do is we're going to take the 1/2 and run it through with our another distributive property, but in this case now it's a monomial times the polynomial. So 1/2 times 2x squared is just going to leave me with x squared. 1/2 times 10x is going to give me 5x. 1/2 times negative 14x is negative 7x. And 1/2 times negative 70 is negative 35. So the area simplified as far as we can for now, is going to give us a equals x squared. I can combine the x's to get negative 2x minus the 35. So now part B basically says find the area basically with this formula without having to go all the way back to the original formula when the shorter base is 18 feet. Well, the shorter base is actually x. So we already know the x value is 18. So what I'm going to basically do is say, well, x's are 18. So I can plug in the 18, and then we can try to solve from there. So when we do 18 squared, we are going to get 324 minus 36 minus 35. When I take 324 and I subtract 36 and then 35, I get my area is 253. And we're referring to feet, so I certainly want to make sure I include the label to be square feet. So 253 square feet would be that small little trapezoidal region right behind the net and on a hockey rink. So basically the multiplying polynomials, very, very similar to the distributive property that we've always done. You just have to remember that each term has to be multiplied by all the terms in the other polynomial. If you're using your two binomials being multiplied together, certainly the FOIL method is a nice way to try to remember how to do that. You could also use the box method, which we are going to investigate a little bit more in when we are doing factoring in the next few sections coming up. Factoring is actually going to be doing the work we've been doing in reverse order. So taking a finalized copy and basically dividing out using that box method. So box method might be one thing that you want to practice a little bit so you can see how we build a product of two binomials, and then the distributive property or the FOIL method is another way that you can do that as well.